Okay, so hello students and welcome to a new video on our apna channel Vashisht Academy. In today's lecture we are going to discuss one important question which is based on electric field as well as electric potential. Basically in this question we need to calculate the electric field where we are given with the electric potential that is equals to x plus y square plus xz. Now how do we calculate the electric field when this type of equation is given of the electric potential? So we know electric field is basically minus of dV upon dr. This is the relation between electric field and electronic potential. For that you need to remember this minus is used for the direction. Okay, na? It is used for direction. For that you need to know one point, that is Ex is equals to minus of dV upon dx, Ey is equals to minus of dV upon dy, Ez is equals to minus of dV upon dz, and then electric field net is equals to Ex plus Ey plus Ez. Okay, na? You need to remember this 1, 2, 3 and the final expression. So this means whenever you are given with the equation of an electronic potential, you just need to partially differentiate it. Partial differentiation means you need to differentiate the whole equation only with respect to the variable that is being written on the formula. So first of all, let us calculate Ex. As we know, Ex is basically negative of V, the value of V, x plus y square plus zx. Okay, na? So we will do d upon dx, x plus d upon dx, y square plus d upon dx, zx. I am doing this for you and you can do the other two by yourself. Okay. So in this you can see that Ex will be equals to negative. Okay, na? Differentiation of x with respect to x will be 1, y square is 0, zx is z. Why? Because whenever you are partially differentiating any equation with respect to x, then any variable or any constant other than x will be treated as a constant value. Okay, so for me, when I am differentiating this whole equation with respect to x, this y square will be treated as constant. Okay, so that's how I got the answer minus 1 plus z. Similarly, Ey, you can do that. X will be 0 because we are partially differentiating the equation with respect to y, and with respect to y, x will be treated as constant. Okay, minus 0 plus 2y plus 0, it will equal to minus 2y. Okay, na? And last, Ez is equals to, Ez will be 0 plus 0 plus x, means it will equal to x. Now for the net electric field, I need to add the x component, y component and z component of the electric field, and the answer will be minus 1 plus z, okay, na? Minus 1 plus z I cap, because x component will be in the x-axis direction. Next will be plus for y minus 2y j cap plus x k cap. Sorry, it is of minus x k cap. See, so this is the answer. This is the net electric field which we have calculated with the given electric potential in an very different equation. Okay, na? So you just need to know that how to partially differentiate any equation. Partial differentiation is basically when you differentiate any equation with respect to some variable. Suppose if I am differentiating this electronic potential with respect to the x in first equation, minus will be treated as minus 1 and it will put the value before the calculation. Now I have to partially differentiate the whole equation with respect to x. Suppose we are doing dx upon dx, it will become 1 because we are differentiating with the same variable. For y square, as you know, while differentiating the y square or another variable with respect to x will be treated as 2y into dy upon dx, but in partial differentiation other variables are treated as constant. Okay, so y square will be treated as constant. That's how the differentiation of y square will become the 0 with respect to x. ठीक है. Similarly, I have calculated the x component, y component and the z component. Okay, ठीक है ना. For net electric field, I have put them all in a single equation. X component will be with I cap, y component will be with j cap, z component will be with k cap. So this was a very important question where we need to find the electric field, and it is the question from electrostatics. As you know, electrostatics carries a very much weightage in your board examination. Okay, we will do more videos upon optics, atomics, nuclei, everything I will cover, try to cover. Semiconductors, basically we will go the deep theory in semiconductors, because semiconductor में क्या होता है ना, काफ़ी deep knowledge की ज़रूरत होती है, हम ऊपर से पढ़ के नहीं समझ सकते. तो मैं I will try to teach those topics very clearly. So keep watching the channel, keep smiling. Thank you very much and all the very best.